One of the most useful features in the software AltAnalyze is the ability to quickly and easily create dynamic heat maps with embedded pathway information without having any bioinformatics expertise. To do this from the graphical user interface, first you just simply select the platform and species of interest after you've installed AltAnalyze, select Continue, Additional Analyses, and Hierarchical Clustering. Once you're in this interface, you can select an expression file. This is a tab-delimited text file where the first row are the sample names and the first column are the gene names. You can have any identifiers of interest or really whatever identifiers you would like. You select a file. In this case, I'm actually selecting an already created heat map from AltAnalyze. In this particular case, it's a ICGS result, which is an unsupervised clustering result from single-cell RNA sequencing data of mouse kidney. But you can select any tab-delimited text file you want. In this case, this file already has been clustered and has a number of pre-filtered features. There's some default clustering options that are selected in the software. If you don't want to recluster a file, but you want to view a file with existing ordered rows and columns, simply select No for rows and columns in terms of clustering, and select Continue. There's a number of options here, and we'll go through those options and how you can use this tool in more detail in a moment. In this case, as the program is displaying, there are 1,400 rows and over 2,000 columns. Each column is a single cell. And this is an already published single-cell RNA sequencing data set. The resolution that appears on the screen is much lower than actually appears in the actual PDF. This is just due to the limitations of the graphical user interface in terms of the resolution. Each row is a separate gene, as I mentioned before. Each color here indicates a different gene cluster. Each column here on the top is a cell with each indicated cell cluster. The white lines in between the clusters demarcate the individual separate clusters. Over here on the right is the first gene listed in each cluster. For space, it automatically does this if there's indicated clusters. And you can always click on any of these genes to get additional information. For example, ACE2. We'll go to this page, this is the angiotensin converting enzyme. That's a key regulator of COVID-19 virus susceptibility. And you can also expand this heat map and produce a more interactive version if you have Java installed. And this will open TreeView, which is also pre-installed with AltAnalyze as well. And you can see it starting it over here based on that prompt. And here the heat map looks a little dark, so you can adjust the contrast settings, for example, just by setting this value equal to 1, for example. And then you can interactively select genes within these files for specific clusters, export this heat map as different file formats if you want to, although a PDF is automatically created along with a tab-delimited text file in AltAnalyze once you generate the heat map, and we can go look at that later. So again, this is a very simple view of the data. These are the default options for visualization. If we close this, it will go back to this main menu. We can select hierarchical clustering again. And if we want, we can cluster any of these features. So in this case, we want to cluster rows now with word clustering. We can just simply do that by selecting word and continue. And so now it's not going to use the ordering that we originally had. It's going to recluster the rows in the file. In this case, there's 1,400 rows. And you'll get a new order and new clusters for those different rows. So this is a dendrogram shown on the right. The left, you can see it does not look as pretty because word clustering is problematic, just like any other hierarchical clustering method. This was a marker ordered heat map that we showed you before, but you see that you can at least change the clustering options and get a new view. I'm going to go back to the original heat map, and I'm now going to say no for row clustering. You can also do very simple things in this program, like change the colors that you want to see. So maybe if you want to view this heat map as red, black sky, you can do that. You can change the contrast here. So we have very high contrast to illustrate where the genes are most highly differentially expressed, but we can lower that. And there's a number of other options here too. So we're just going to select that and see what that looks like. There's a number of different color options there that you can play with. Importantly, in this case, there are some groups that are already designated in this file already. You can see how those options changed. You can actually change these groupings and control them if your expression file starts with the prefix exp dot, and then you have a second file that starts with the prefix groups dot, groups dot, with the exact same file name thereafter. The groups file is a 3-column file. The first column is the cell IDs, or unique identifiers, the column IDs. And the next column is a number for each individual separate cluster, which you define for these different cells at the top. And the last cluster is the name of the cluster. In this case, these are just numbered clusters, but you could have the name of these clusters be T cell, neutrophil, or whatever, and they would be displayed here at the top or displayed down here in the legend. You can also put additional metadata in the groups file to view in here in this type of file. So those are some very basic options for generating heat maps in the software. But there are actually a number of advanced options which give you a lot more creative control over what types of heat maps you generate. And so if we expand these options, you see a number of these options. First, you can modify which clustering algorithms you use. So in this case, I was defaulted to cosine for columns, but we can actually use a number of different algorithms. The same for rows. Again, we can change a number of different algorithms. We can change this option to more sophisticated clustering methods such as HOPAC, which are present if you have R installed and HOPAC on a Mac, but are available by default on a PC. They're pre-installed with AltAnalyze. You can change the expression normalization from median level normalization to mean or to nothing, to just look at the raw expression values. You can transpose the matrix. You can change this contrast option, which is going to change how bright the data is, effectively change the fold change range that we saw in the previous heat map. Importantly, there are a number of advanced options here that we're now going to go into. The simplest to use is the pathway enrichment analysis option. So if we say, for example, select pathway commons here and continue, what's going to happen here is the program again is going to use the existing clusters, but now it's going to use this embedded tool called GoElite. And what GoElite will do is it will perform a pathway enrichment analysis per gene cluster. And so the genes within those different clusters will now be detected, and pathway enrichment will be performed on them using the pathway commons database. And what will be displayed as a result are the associated enriched pathways for each one of those gene set clusters. This sometimes can take several minutes. We're going to skip ahead. So the analysis is complete, and as you can see, there's this folder that popped up in the background. This folder contains the actual enrichment analysis results. There's actually a large number of files there. The primary file is this pruned results z-score elite. If you open this in a tool such as Excel, you'll see some of these clusters did not have any associated enriched pathways, while others did, and you can see the list of these pathways. The numbers of genes changed. The specific genes that were within that pathway that were identified, whether some pathways are redundant to each other in terms of the gene content for those that were enriched, and so on. You can also gain access to specific networks that visualize a lot of those associations per cluster. So these are the specific genes that are associated with these specific cell types, and you can see some redundancy in different cases. Within the actual heat map itself, you see you get visualization results for the different pathways that were enriched here. You can actually click on these terms and they'll bring up some of those networks we're just showing you. But this is a nice way to see basically what terms are associated with these different gene sets. There are a number of gene sets in the software, so not just these pathway-based gene sets, but there's actually specific gene sets that indicate what cell types these likely are based on prior described marker genes. So in this case, these are marker genes that are obtained from over several hundred data sets, I believe, studies, and over 1,000 gene signatures for, in this case, mouse, that exist that you can also analyze using the same method. So again, this analysis program resulted this program produced a pruned results z-score elite file, which contains associations now for cell types rather than pathways. If we go back and look at the heat map itself, you can see, although it's hard to see here, there are actually enriched cell types now for each one of these clusters. Since this is a mouse embryonic kidney data set, and there should be mouse embryonic kidney terms here, we should see enrichment, and we do, for example, for embryonic medullary collecting duct. And you can see that there are actually multiple terms in some cases reported based on how much the program can basically fit little labels onto the left side of these heat maps to, again, indicate what the likely cell types are. And you should see some similarity between very similar terms that are associated with the same cluster. In addition to these gene set enrichment analyses that you can directly perform within the clusters, you can also perform some dynamic filtering within these heat maps that gives you an ability to really customize how you want to display and what you want to display. So for example, if you see this option, type a gene to get top correlated. We can type any gene as long as it's within that tab-delimited text file that we're loading above. For example, ACE2, which we pointed out before. And in this option here, get all correlated genes with rho. And rho is basically a Pearson correlation cutoff. In this case, I'm going to list this as 0.1, very low. And it's going to give me both genes that are correlated with ACE2 and anti-correlated. If we only wanted to get positively correlated genes, we can select this additional correlation options and say positive correlations only. In this case, we don't need to redisplay these biomarkers, so we're just going to get rid of that option. By default, the program only selects the top 140 positively correlated and the top 140 anti-correlated genes. In this case, there were, of those 280 possible genes, there were only 273. And what you'll see in this heat map here, again, is that you'll see ACE2 and all the genes that are correlated with ACE2 and all the genes that are anti-correlated with ACE2 in this data set. These are the original cluster identifiers that were in the input file. You can actually load multiple genes in here. So for example, we can say ACE2, 6-1, SLC 23A1, whatever you want. And you can get the precise correlated genes, or if you want, you can actually just see those genes. I actually don't know if those genes were within this data set. 2 of them were, and so now it's just going to generate a heat map with those 2 genes. Again, with the same cluster order. And in this case, it says 23 because this was the cluster ID. That's how it's encoded in the file. It's 23 colon ACE2 and 3SLC 23A1. You can also specifically just display whichever genes that you want to within the heat map that already exists by pasting them here. We've gotten rid of that correlation option. And if we again say continue, it's just going to simply call out whichever genes that we want to in the heat map to the right that are present. If you generate any custom gene list in the program, through correlation or whatever, you can actually optionally store that gene set just by simply giving it a name. For example, ACE2 correlated. And this will actually be available up here. So we're gonna actually generate that ACE2 correlated set again. We'll maybe actually only make it positively correlated. Go back. We can now remove ACE2. We can remove this correlation option and this label. And now if we go back, if we go to this option, select gene set ontology to filter on, there's a number of different pathway databases and gene sets to select from, similar to the pathway enrichment. One of these options is called stored gene sets. In this case, there's ACE2 correlated that we have here. And if we just say view those genes now, it will simply just restrict the analysis to those ACE2 or visualization of those ACE2 genes within the heat map. Similarly, we can actually select wiki pathways gene sets, and so there will be a number of wiki pathways associated gene sets here that we can select. Any of these genes that are within that heat map, the program will automatically filter for these different gene sets and visualize. You can do the same thing with biomarkers or gene ontology terms or anything else that's stored here. There are a number of other ways to actually manipulate the heat maps, including showing custom groups, which require that your tab delimited expression file have a prefix. That prefix is exp, as an experiment, .exp, a name, for example, cancer, in a groups file in that same directory, which has groups, groups, .cancer, for example, .text. The groups file has 3 columns in it. The first column is the header row within the expression file. The next is a number that corresponding to each group. And then the final third column is the name of that cluster or cell type that you want to designate, and that will show up as an additional color bar within the heat map. We recommend you play with these different options. If you have any questions, please contact us, or if you have suggestions. Thanks again.